Hello and welcome back. So far we have understood covariance and correlation. Covariance actually shows you the direction only, and correlation shows you the direction and strength both. The sign, the positive sign and negative sign of the score actually gives you the direction, and if the number is between -1 and 1, when you calculated correlation, it gives you strength, right? If it is close to 1, too strongly positively related. If it is close to -1, it's too strongly negatively correlated. If it is close to 0, no relationship at all. This -1, +1 and scores close to -1, +1 and 0, this concept is for correlation coefficient. That correlation coefficient gives you the strength and direction both because it is standardized. Let us try to understand more about correlation. Correlation always shows you the linear relationship. Let us look at this diagram here and the graphs. I have taken a linear dataset and non-linear dataset. What I mean by linear dataset and non-linear dataset is the input feature and the output feature are linearly related. That means when one is increasing, the other is also increasing. When I say non-linear relationship, in this particular dataset, for some time when the x is increasing, the y is decreasing, right? The input feature is increasing, the y value is decreasing. At some point, from some point onwards, when x is increasing, the y is also increasing. So it is non-linearly related. So I have taken two example datasets and tried to calculate the correlation coefficients. For the first dataset, it gave 0.98 as the correlation coefficient. That actually looks reasonable because the x is increasing, the input feature is increasing, y is also increasing. When you look at the graph also, it is showing a linear relationship. When one is increasing, the other is also increasing. But in the second data set, when I calculated the correlation coefficient, it actually gave me -0.23. A negative correlation, that too close to 0. When you look at only this number, you may think that there is no relationship at all between the input feature and the output feature. But when you do a graph, a scattered chart, scattered plot, it actually shows you a non-linear relationship. So why am I showing all this is, not just by calculating the correlation coefficient and looking at the number, you cannot decide the strength or the relationship between two features. There may be a non-linear relationship also. Always it is suggested that calculate correlation, look at the score, and then try to do a scattered plot like this and look at the relationship also. If the scattered chart is showing a non-linear relationship, then the feature is important in predicting the target variable. There is some pattern, right? When there is pattern, the feature is important. That may not be correlation, right? Strictly, it is not needed to have correlation. There should be some relationship between input variable and output variable to make predictions. So that actually says that, that actually shows you or demonstrates you, and correlation actually gives you linear relationship only. Let us try to look at the code example. How exactly I have done these scatter plots. So here I have taken the linear data set. These data sets are available in our data folder and along with your section, whatever section you are looking at. So I have imported that and loaded it into a data frame and looking at the head, and then I am trying to do the correlation. I am trying to calculate correlation between the input feature and the output feature. Again, in the series object, we have got CORR method, which actually takes another series object and tries to calculate correlation. To visually see what is happening there, or scatter plot, we have the scatter method in PLT, where it takes X series object or list, Y series object or list or numpy array, and you can actually plot it. It is simple, right? So here I have taken the margin major pad 10 X ticker. I am just trying to give some padding between this X axis and the numbers. That's it. If you increase and try to play with it, you will see the difference. And I have taken the polynomial data set and then try to look at the head, right, in the data frame, and then calculated the correlation. And when I try to look at this correlation coefficient, it actually giving me 0.22, or when you try to round it off, it is going to be 0.23. When you look at that number only, you may think that there is no relationship, or the input feature is not strongly related to the output feature, and we may not be able to use it in machine learning algorithms to predict. But when you look at the scatter plot, the actual relationship is visible, clearly visible there, right? So it is always suggested that you calculate the correlation coefficient, look at the number, and then try to do a scatter plot and look at the the graph and see the relationship, and then decide whether to keep the feature or remove the feature. This is one of the aspects in feature selection. We'll talk about feature selection more when we do machine learning algorithms. There are automated approaches to do feature selection, so we'll talk about them there. Thank you.